My name's Peter Bakas. I work at Netflix. Before we get started, I want to kind of take a gauge of the crowd. How many folks are on the data science side, data engineering, infrastructure? So how many folks are data science? Okay. And the engineering side, data engineering or infrastructure? Okay, cool. All right, so let's go. A little bit about, here we go. A little bit about me. As Pete said, I run real-time data infrastructure at Netflix. Prior to Netflix, I spent time at Uyala, Yahoo, PayPal, everything from payments to behavioral targeting to display advertising. My background is primarily distributed systems, large-scale infrastructure. When I am not at work, I advise several startups, primarily around data, security, and containers. So if anyone's at a startup and want to talk about something, always happy to take a call or an email and chat about what we've done, what I've seen, things of that sort. So always happy to try to help as any way I can. All right, so Keystone. Keystone is our common data pipeline. How many people here are familiar with data pipelines and data movement and things of that sort? All right. How many people here realize that's a very big problem at a lot of organizations? All right. So the job of my team is to essentially provide the paved path for your data engineers and data scientists to be able to do what they need to do. So at Netflix, we have a concept of paved path. It's the way that everyone can use a service to be able to do what they need to without having to build the infrastructure themselves. Now, having said that, Netflix is a culture where we believe in freedom and responsibility. And so if someone wants to go off-road, they're fully free to go do what they need to do. We optimize for agility and not necessarily for efficiencies. So if someone comes to me and says, hey, I want you to be able to do this, and it's not on my roadmap, or I can't get to it in time, they're perfectly free to go do and build what they need to so that they can deliver their product and their service in the manner that they need to. Now, having said that, when you do go off-roading, sometimes you get stuck. So what we try to do is really build that common paved path for people. What I'm hoping to talk about today, I want this to be interactive. These are some things I put down. If people have questions, please ask. For every question that is asked, Pete has a Netflix bottle opener. In the form of a question, sir. In the form of a question, you can get one. So I want to talk through the architecture, design principles that we put in place while we were building Keystone, some of the technologies. By the end of this, it will be buzzword bingo. So there's a lot of technologies in place, but also best practices. I think one of the things I want to have people take away is even if you're not at Netflix scale, there's certain things and certain ways that we've done things that could benefit people. And that's, hopefully, whether you're doing 1 million events a second or 100 million, it doesn't matter. There's still some principles and best practices that could help. Okay, so how many people here know what Netflix does? So you think. We're really a logging company. I believe Adrian had a quote about us being a logging company. That occasionally streams movies. And this is true. So what does that mean? That means, and here's the big numbers, we ingest over 600 billion events every day. At peak, we do 11 million a second, about 24 GB. Hundreds of different event types, over 1.3 petabytes a day. So this is daily numbers. What are these events? These events are things like session, trace annotations. They're business events that we use to do things like build recommendations, things of that sort, A/B test, streaming client logs, things of that sort. We don't handle operational metrics. So this is purely on the application server business event side. There's another system called Atlas that's been open sourced that handles all the operational metrics. And so it's kind of been decoupled between the two systems. Ha ha ha. So we process over 1 trillion events every day. This is handled in our routing service. We also hit 1 trillion events ingested. These are all unique events during the holiday season. So while everyone was home over the holidays, watching Netflix, not spending time with the families, we were at about 1 trillion events. So now if you notice, we've gone down, and I'll talk a little bit about that here in a little bit. While it's great to stand up here and say, look, we do 1 trillion events, and we could check that off, our philosophy is really we want them to be useful, right? So producing an event for the sake of producing an event doesn't do anything besides put like really big numbers on. So as data scientists, as data engineers, you know, people talk about big data and fast data. It's really useful data that we want. So at this point, I want to take a step back and talk about where we were about a year ago, a little bit over a year ago, and why we made some of the decisions to move to Keystone and build Keystone. So originally, our data pipeline looked like this. Very simple. We had events being produced and collected. Ask a question and you get a bottle opener. Based on Apache Chukwa. So essentially, application services would publish events, we'd collect them, we'd write them to S3 for all our offline processing. So very simple, great, things work great. People were very happy until they weren't. So a little bit after that, people started wanting to have the ability to do things like at least once, real time. And so we created and introduced a branch off mainline that's heat traffic into Kafka. We routed it to Elasticsearch and secondary Kafka clusters, where then it was consumed by either consumer purpose-built applications, Spark, Mantis. Mantis are open source, or it's not open source yet. It's our in-house stream processing system that we have. So that's conceptually where people consume either from this Kafka or that Kafka. The problem that we found is there's a lot of duplication. If you notice, there's a lot of functionality that's very similar. It also confused a lot of people. So producers come and say, hey, I want to produce an event. Do I send it through here? Do I send it through there? What happens if I need guarantees? And so about a year ago, we decided we wanted to be able to simplify what we had and be able to start offering higher level services. So as we looked at this, we said, okay, well, we need to be able to do at least once. People want to be able to do things in real time. So we could invest and build things ourselves, or we could look at what's out there, what parts of our infrastructure provide some of this functionality, is there a community behind it, and what can we do? And so what we decided on was this. So if you look at this pipeline, it's much simpler. We've essentially flattened out what we had before. So we removed Chukwa, we put a fronting Kafka, so essentially handle the fan in, handle the fan out. The routing service is different. I'll talk about that in a minute. So when we were looking at the routing service, as we're adding in durability and at least once, if our routing service was not able to provide the same semantics and SLAs, it served no purpose, and so we ended up using Samza, and I'll talk about the routing service and what that looks like. But the primary point of doing this was, well, being a snowflake is awesome. Common core infrastructure is not that different. And what we want as a team is to innovate where we can provide additional value to the business. So when we looked at Kafka versus what we were doing, at least once, had durability, had a huge community behind it. And so we decided that our effort was better spent getting Kafka to where we needed it to be versus writing it completely over ourselves. Now, having said that, there are challenges. Kafka was designed to run in a physical data center, running in AWS. There's different challenges that you have to adjust with. But for us, it was better to try to solve those problems than to be the only company that had something that no one else was using, and we had to support the entire thing ourselves. Folks here know Kafka? Okay. All right. So I'll skip through this stuff. Unless someone's curious about Kafka, we could talk about it afterwards. There's a lot of great material out there that people could read up on. So common terminology, you'll hear producer, consumer, topics, partition, brokers. This is a very, if you Google Kafka, you'll probably see this. All right. So one of the things that we do differently is we don't use just a stock Kafka producer. What we've done is we've put a wrapper around the Kafka producer for a couple reasons. For us right now, it's best after delivery. We prefer drop than block. So our philosophy is we should never block an application because the point of our service is to stream movies. And so that is the important piece. So if an application or service needs to do their function and they block on the ability to send an event, that's bad. So our philosophy is drop, not block. The other part is integration into our ecosystem. So like Eureka, Atlas, things of that sort. So for those who have used Netflix open source software or know about it, we have a ton of stuff that we've built, and so it's a lot of integration into our services. As I talked about, philosophy is not to block. So if we have an outage, the existing application should be able to perform their function. So if that's doing playback of a movie, they should be able to do that. Because they can't send an event should not mean that your experience is any worse. At the same time, if all of a sudden we get a need to scale up or launch new instances, because our service is not available, does not mean that your service should suffer. You should be able to operate your service in the way that you need to. The other one is once we restore service, it shouldn't require you guys to do anything. Your application should be able to start sending events again, just like normal, without requiring any action.
Do you cache the events or just start from zero at the moment?
So we provide a buffer on the client side, and I'll talk about this a little bit later on, but once you fill that buffer, it'll start dropping messages. And so there you go. You really wanted it.
Yeah.
It's nice, isn't it?
There you are.
So you say you prefer drop over block?
Yes.
I mean, that's overall also of the protocol you prefer to UDP?
What was that?
You also prefer to UDP?
Yeah. Yeah. So in general, our philosophy is, like I said, we should not block like any other services. Having said that, one of the questions that we are talking about right now is the value of data, because not all data is created the same. And so there are certain events that we don't want to drop. And so now how do you create a different class of service to ensure that those events go through versus other ones? And so when I talk about higher level services and what we offer, that's the stuff that we're talking about. It's like, okay, data is not all created equal. What does it look like? Do we need to have multiple copies of this? Do we need a guarantee? Do we need to provide quotas so that since it's a multi-tenant system, if you're behaving poorly, it doesn't affect someone else? And those are kind of some of the questions that we're starting to have right now. What are we partitioning? So right now what we're doing is we have each event type is a topic, and then based on volume we'll partition across. Now, part of it is we need to make sure that clusters are balanced. because otherwise what you'll do is you start seeing some interesting behaviors. But that's kind of what we do. There's some work that's being done on automatic rebalancing and things of that sort that'll be coming out. But yeah. Other question?
So in terms of these like best effort, have you guys just tried implementing kind of like a retransmission?
Yeah, I mean, so that's we're doing. So this is V1 of the new pipeline, but there are a lot of conversations around, retries and what does that look like? What signals do we provide back to the application? So right now we assume a lot of the responsibility as a service. What we want to do is we want to provide signals back to the apps so they could decide what they do with it. You could decide on your own, this is really important, I want to do a retry, or I want to write it temporarily somewhere else, and then send it. Or I could say, you know what, this isn't an important message, I'm going to drop it. But we don't have the ability right now, but that is work that we're looking at doing.
How are you guys detecting if something was dropped?
So we control libraries, so we could see what's sent versus what we ingest.
Yeah.
So how do you guys manage, it's just one cluster? But
No,
so
we'll get to it. So your buffer question right here, see? So we drop when we full buffer. The other thing that we do is we do only one ACK instead of two. We don't want to wait for that second ACK in case that takes a while. We don't want to block on it. So we're willing to lose a message rather than wait for two ACKs. Now, having said that, as we start looking at a higher quality of service, there may be situations that we do that. So. All right, sticky partitioning. We batch when we produce events. Primarily, we want to be able to reduce burden on CPU and network. Yes?
sorry, just going back to that other previous slide. So let's say I can't afford to drop.
Mm-hmm.
Can you recommend an architecture where I can sort of handle that situation?
Yeah, I mean, part of it is you could do things like you could write to disk. There's other things you can do temporarily to weather a situation. What we've designed for is on the producing side, and our biggest challenge right now is around the producer and dropping events, especially as we're running at scale. Once you start getting replication lags, things of that sort, you have brokers that are misbehaving. And so we don't have a huge buffer because we don't want to have, take up a huge amount of memory for all applications. There's a couple other things we could talk about. Some of the strategies that we're looking at, and depending on what events you're doing and things of that sort, retries and things of that. But we could, if you want afterwards, I'm happy to, for deep questions, happy to go in after. We talked about batching. So how do you produce events? Using platform library. It's a log event, it's annotatable. We also provide, so Netflix is primarily a Java shop, but there are other languages that are around, and we're starting to become more polyglot. We do provide a proxy service, so if you're running Python or something else, you can access the service. Same thing with the sidecar. We inject metadata, so GUID, timestamp, host app. In general, we have our own wire protocol. It's invisible to source and sinks. We currently support JSON with Avro on the horizon. So that's kind of legacy of where we were. And so in our migration from the old pipeline into the new, we wanted to minimize the moving pieces. And so this actually did cause a little bit of an issue. So we had the old pipeline running. We essentially shadowed traffic onto the new one as we were building it out. And when we changed our wire protocol, we actually introduced compatibility issues downstream. And so in hindsight, so this is one of the ones, if you're doing a massive migration, try to minimize the number of moving pieces and make it as simple as possible. This probably added, weeks to our timeline because we had to go back and validate because now we had to introduce a change. And we did it for the right reasons. But in hindsight, like I said, it's one of those things where it's like, okay, if you can minimize, get from existing legacy onto new, and then iterate afterwards. Having said that, the entire process was about a year. And so we ran from where we kicked it off to end of last year where we cut it over. As I talked about, 600 billion events or whatever, we were actually doing 1.2 trillion because we were shadowing both. So.
What was the reason for choosing Avro instead of Parquet?
So we haven't. So Parquet is for. So we do use Parquet, but that's on the HDFS side. So we'll have to actually translate. We'll have to transform from Avro to Parquet. So what we do is, as a sequence files that we deliver to S3 for EMR for all the Hadoop stuff, they use Parquet. So, but I'll go into that's a highly contested conversation at Netflix right now. But I'll talk more about that. And anyone who's interested in Avro versus anything else like protobuf, or we could go into that. So we did package this as a jar primarily because we wanted to be able to evolve it independently. It is fairly lightweight. We don't add a lot of size to each event. The other thing that we have from legacy is a 10 MB size on events. It's a pretty big event. We are trying to move down to supporting probably 1 meg, but this is one of those things where we decided not to introduce changes that our producing apps would have to do. So, okay.
How is that affecting the performance of the Kafka process to have 10 megs?
So that's where you have to. So it's very batchy. So typically, what happens there? It's not a constant, steady stream. Is the app that's sending it is in there, and it'll batch to that size and then send. But it makes it a little bit more complicated as far as now balancing what your bytes in are and things of that sort and whatnot. And part of it is our philosophy. Our average payload size is a couple K. And so to be an order of magnitude. So those are conversations that we have to have with the team, and they have good reasons for doing it. But one of the things we've talked about is like, okay, well, what if you write that to S3 and then just send a location through our pipeline, and then your app can pick it up afterwards. So we're trying to work with those teams, but ultimately we want to drive that down to about 1 meg. Like I said, especially given our average payload size, I think that's fair. It's fair.
Quick question.
Yes.
So let's imagine that the Kafka cluster goes down for some reason, and all your producers have their buffers full, and then it comes back online. Do you have, are you implementing some kind of flow control, congestion control, so that they don't just...
Yeah, so what'll happen is we'll drain what's in the buffer. So what'll happen is you'll fill up the buffer, all the other messages drop, it comes back up, what's in the buffer will get flushed, and then they'll start producing.
Yeah, but will the cluster, is there a chance that the cluster will get overrun by all those messages?
So we've provisioned for peak plus. So part of the challenge that we have is being a stateful service. We don't necessarily have the ability to autoscale yet. We're working on that. Scaling up's a little bit easier, but we've had to provision for peak plus failover. And so while it is possible, we haven't seen that. And usually what'll happen is we won't lose like everything. It'll be isolated. And I'll talk a little bit about the fronting Kafka and the purpose that it serves. So if you look at the architecture, we have fronting Kafka, and the sole purpose is to essentially create a buffer to be able to sustain all incoming requests. So that's, like I said, provision for peak plus failover. So from a failover perspective, if we fail out of a region, we'll shift traffic And so we've calculated what that is, and we provisioned for that. And we have the ability to add additional partitions and things of that sort. But now, if we do get overwhelmed, once again, the intent is to drop. What we've done here is we've actually, it's not one cluster, it's 8 clusters per region. So we run 8 clusters per region, so we have 24 on the fronting side. We've also isolated on the Zookeeper side. So each cluster has its own Zookeeper cluster. So the reason why we ended up doing that is we did have a situation where a Zookeeper leader re-election caused some interesting behaviors. And at the time we were running 4 clusters, something like 14 or 15,000 partitions in one of them. And those clusters just weren't able to recover after that re-election. And so what we decided at that point is to minimize our blast radius. We split it up into smaller clusters. And so now we kind of max out how many partitions. And if we need, we'll just add new ones. And each of those clusters have their own Zookeeper.
What are the optimal cluster size?
So we try to keep it under 200 nodes per cluster. And partitions probably around 10,000. So, other questions on that?
So what was your problem with the re-election of Zookeeper? Because I heard something similar to PagerDuty, and they traced it to a kernel bug.
Yeah, I mean we'll get into that. It was a long night, and yeah. So we could talk about that issue and a lot of the network things that we're seeing, especially being in a cloud. So for folks out there, we're EC2 Classic. Most everyone out here that's in Amazon's probably VPC. We'll be migrating to VPC this year, and we should get a lot better network performance. And so, like that's for us that's a big incentive. But yeah, I'll go into details about what happened and why it was a long night and yeah. So in addition to those 8 clusters, what we do now is we have 2 priorities, normal and high. Pretty complex stuff, eh? So as I mentioned, the fronting Kafka is a buffer. And what we've done is based on priority, we have a retention period of 8 hours to 24 hours. What this does is it allows us, if we have a downstream event, if something's going on with S3 or we have some back pressure with Elasticsearch or something happens with the routing service, it allows us that long to be able to handle an incident without losing messages. And so, you know, we do 2 copies, 8 hours and 24. We are going to offer the ability to select 1, 2, or 3 copies, depending on priority. What we want to do is we want to push a lot of what we're doing now down to 1 copy. Like I said, it's what's the value of data, right? There's certain things where we want to make sure you don't lose. There's others where some loss, it's okay. And so as we're going through and looking at things like cost attribution and the value of events and whatnot, we want to be able to split that out. To start with, we went with 2 copies.
Could you give a concrete example of like some events that you would consider high priority versus those that would be low priority?
Billing versus error logs. Password changes versus a sign up versus someone doing a trace on their service. So, and there's other things that we then use for recommendations or A/B tests. So you don't want to lose certain events because now that may skew your results for an A/B test, and all of a sudden you're getting recommendations that you're like, what? So, so that's kind of an evolving piece. So we'll see how it goes. Before we go to 1 copy, there's a lot of producer improvements that we need to make. Right now, where we lose the majority of our events, and you know, by loss we're talking 0.0001%, but it's it's from the producer to the broker. So size-wise, we have over 3,000 nodes, 3,000 brokers that we run for Kafka. That's spread across 3 regions, multiple AHGs within each of those regions. We are using D2XLs. For us, it was a balance between performance and cost. Those are newer instance types, but yeah, that's kind of the footprint there. We do replication assignments that are zone aware, and this has some benefits for us around availability. So if we lose an AZ, it's okay. We still have other AZs where data is distributed, so we don't have loss. We also can sustain a host failure. So if you have a host that has multiple instances on it, we're still okay. An added benefit of us being able to do this is around cost of maintenance. We now have the ability to remove an entire AZ, upgrade, perform any maintenance, and add it back in. And so that was kind of a nice side effect of us gearing for a higher availability.
Is there an impact to customers when you take one down?
What was that?
Is there an impact to customers? When you
No. So we have the ability. It's like I said, it's seamless to our customers. They don't know the difference. We also have. I guess I could talk about this. This would be good. So part of our failover strategy is in region. So we have the ability to spin up a new cluster, shift traffic there, do whatever. So if we have a cluster that's having problems, we can essentially just route traffic to a new stand-in cluster, resolve it, blow it away, whatever, and then once it's resolved, shift it back. So we have that. It's all automated. So if there's loss that's happening, we have very tight SLAs as far as how much data we could lose. And so if something's happening, we'll spin up, route. There is a time that it takes to be able to provision. That also has its own Zookeeper cluster that we use. However, it's shared amongst all the failover clusters. So each of the 8 clusters has their own, and there's an additional 9th one that if we have to fail over any of the other clusters, they would use a shared one. But we figured from a risk perspective, we're okay with that. So that's one of the things that we've worked on over the past few months is the ability to seamlessly do in-region failovers and whatnot. One of the services that we have is an auditor, Kafka Auditor. It's actually really, really useful for us. We will be open sourcing this over probably the next few months, hopefully a little bit before that. But it does provide us broker monitoring, consumer, it does heart beating. We can do performance metrics with it. It's a standalone service. So we'll be open sourcing that. And it's a lot of the things that we use to see the health of our system, we use our auditor for. Current issues, as I mentioned, trade-off between cost and performance using the D2XLs. We've noticed that our performance does deteriorate the more partitions we have. And so we try to limit. So we could do topic migrations. So we have the ability to automatically migrate topics over and seamless as far as loss for customers and whatnot. And we also see a replication lag. So one of the things that we're interested in with one copy is to see if our drops actually go down because we no longer have that replication lag that's causing some anomaly within that broker that is being trying to be written to. Routing service, any other questions? So the problems that we had with the D2XLs were they were new, and initially a lot of the placement. So we had one physical host that had a lot of instances, and so if something happened to that, it would actually, we'd see large amounts of brokers going offline. The density's gotten a lot better and the placement's gotten a lot better. I am interested to see how it is in VPC. The one of the things that we're looking at is actually going with a larger instance type. So we'd go fewer, but we'd have more. And so we wouldn't have the noisy neighbor. So some of the times we see some of that pop up also. We have looked at other instance types. We're starting to experiment a little bit with EBS as well to see what that looks like. Preliminary results seem pretty good. So there's a lot of performance improvements that we're looking at over probably the next few months. And from instance types to what kind of storage we're using, things of that sort. And part of it is if we can now start saying we need lesser retention or have more network bandwidth, we can start playing with some of those configurations. But for us, the D2s, from a cost performance, kind of blended. It was kind of in the middle. And so, so we worked out a lot of stuff. Amazon's been great with that. So they worked with us really closely early on as far as like troubleshooting what the issues were and whatnot. So Amazon's been a great partner for us in that sense.
So is everything hosted on Amazon or anything?
Yes.
Is there nothing on the platform?
Nope. We're all in.
So two questions. First of all, what automation tools are you using to manage all this? And the other question actually forgot.
All right, so I'll do a little dance while you think about the other one. So we have a lot of in-house built tools. So the one area, for those who are using Kafka, there's a lot of things that we've built. We're focused, and I'll talk about this later, around self-service. These are just common things that everyone has to do, whether to manage their environment or how you do topic creation and things of that sort. So if anyone's interested in collaborating, please reach out to me. The one thing that my team is passionate about is working both internally and externally to try to solve these problems. Like I said, we're not a snowflake. The reason why we chose to go with something that has a big community is because it has a big community. And granted, some of the challenges that we have due to scale, other people don't have, but how you manage Kafka, whether it's 10 nodes or 3,000, you still have to manage it. So if people are interested or doing stuff, glad to collaborate. So, did you remember? Did I stall enough? All right.
So in terms of failure simulation,
Mm-hmm.
do you guys what do you use, Chaos Monkey or Chaos Burrito?
Yeah. So in general, we routinely fail out of regions as a company. We do exercises all the time where we'll shift traffic around. We run Chaos Monkey on brokers. They die all the time. One of the reasons we went to an isolated zookeeper is because we didn't necessarily want our blast radius. So, I mean, we have leader reelection happens all the time, and the most part it works fine. But part of it for us is risk mitigation. But I talked about our failover strategy. We routinely practice it. So just having the conversation this morning with my team, first thing that on-call does is fail over a cluster, because then it works. So every week where someone's new, we fail over at least once a week, and that's just how we know things are going to fail. The question is how fast can we react? How do we mitigate the risk? What's a blast radius? How do we communicate to our upstream and downstream partners? What's our SLA? What visibility do we have? And so, yeah. I mean, we have a small team. It's 9 engineers. And most folks are relatively new to the team. Over the past year, we've built the team out. But the way we test failure and the way we automate, it's the only way we're able to manage something of this scale is through automation. And there's a lot of effort being placed in self-healing systems. So if something's going on with a broker, we'll just kill it and replace it, right? Because we have a very tight SLA. And so being able to detect those signals and instrument things in such a way that if this happens, automatically just kill it, bring up a new one. So that's a lot of effort that we've put in, especially over the latter part of the year, to try to productionize things so that when failures do happen, like the big one we had, we're able to react and mitigate what the risk is to the business.
Are you running this in containers or just?
This we are. So Kafka we're not, or routing service we are. So if you look at, great segue. You should get 2 bottle openers. So our routing service, based on Samza, here I'll go in a little bit about a topic. Most people sound like you're familiar with Kafka and topics and things of that sort. So Docker, MySQL, Samza, and a checkpointing cluster. So we did a significant amount of work to Samza to be able to run it in standalone. We run it in containers. We use MySQL to be our system of truth. So the way our routing service works is you have jobs that are assigned partitions, and their job is to read those and move them to whichever sync. So it's a per topic, per sync. We run in containers. It is a fairly simple overall service, but very complex SLA around what happens, how do you launch, and whatnot. We do have the ability to auto-scale our routing service. And so if you look at what we're doing, we're running about 13,000 containers in production, about 1,300 hosts. We actually had less containers, more hosts. We've done some optimizations over the past month. Part of that is, as we were rolling out our service, our focus was on being able to move from old service onto new, knowing that we could do performance improvements and minimize some of the spend and whatnot. But yeah, so we're up to 13,000 containers. Most of them are fairly similar. They handle between 1 and 12 partitions. We pack across a box fairly consistently. We don't have a need for any complex scheduling because our jobs are very much long running. The breakdown is 7,000 for S3, so that's all the offline Hadoop piece. We have 4,500-ish in Kafka and another 1,500 for Elasticsearch. The thing that's interesting is that's about a 55-45 split. When we first started, so when I started Netflix a year and a half ago, we were only doing about 15 to 20% on the real-time branch. So what's happening is we're starting to see a lot more workloads and a lot more desire to do things in real time. We've seen a huge explosion in the number of Elasticsearch clusters that are running on nodes. And like I said, you're starting to see a lot more folks interested in the real-time piece. One of the things that we're doing on a self-service perspective is giving people the ability to also determine not only their quality of service, but their destination, so it becomes opt-in. So right now, everything ends up in S3, whether we want it or not. There are certain events that we really want to process them right now, and after that, it doesn't matter. But by default, everything, and that's kind of from a legacy, if you looked at the original pipeline, that was the sync.
So before you move, why are you using Dockers? Everybody loves Docker. Or in this case, you have
Good question.
you could use micro instances, and now you're running XL. So
Yeah.
what was the
So technically, we don't need to run in containers. So our routing service is the start of our stream processing offering. And while routing service is very fixed as far as resources, we know what it looks like. When you're doing general stream processing, you may have a huge difference in workloads. And so we want to have the ability to offer people to be able to do different workloads across a shared infrastructure. And so for the routing service itself, it was an investment in where we're going versus where we're at. Does that make sense?
It's kind of like faster, right? Because you don't have to spin the instance, it's just
Yes, I mean, we have it, and so part of it is if you start looking at the ability to manage resources across, so eventually what we run here, there'll be other workloads, not just processing workloads. And so the ability to do resource management appropriately and then use your peaks and troughs, you become a lot more efficient. Also kind of the isolation and whatnot. We could, for this, for all intents and purposes, we could have ran it and spun up VMs for it. But for us, it was an investment into where we're going versus doing something temporarily and then having to redo it down the road. So yeah, I mean, for routing, it wasn't necessary. Five, all right. More numbers. People, I'll post this up. People can grab it. As I talked about, we have isolation per job, per sync. So each job reads from a topic, certain number of partitions, and it'll write it to the appropriate destination. I'll get your question after since we have 5 minutes. A couple things there. The isolation's good. One of the problems we had before was we had a routing job that would write to multiple syncs, and so if you're getting backpressure coming up from Elasticsearch, it would then cause other jobs to back up as well. And so from an availability, from a balance perspective, we ended up splitting those out. Let's see, talk about at least once. So our intent is to offer at least once. Once events get into Kafka, we have pretty good ability to do that. However, as I mentioned, our biggest issue right now is from producer to broker. We are putting a lot of work into it. The 0.9 release helps out a lot. So we're currently in process of upgrading to 0.9. We have the test environment, we're evaluating, and we'll be doing that. So hopefully that should solve some of the problems that we have. Data loss we touched on. Basically buffer full, network errors. So from a Kafka perspective, the ability to be spread across multiple AZs allows us to mitigate some of that risk. But it can happen if you have an unclean leader election, especially since we have a hack of one. So if you write to a broker before it replicates, if something happens, we do have that potential. We haven't seen that, but it is a risk that we do have. At the router, loss is less likely. Duplicates are probably more so. But from a loss perspective, if something happens in a routing service and you exceed your 8 to 24-hour window, you do have that potential. Also, what we've done there, as I mentioned, we've spent a significant amount of time around monitoring and alerting. We have threshold alerting for anything above 0.1. The intent, as I mentioned, the intent of the fronting Kafka is to buffer. The intent of the routing service is to read and move as fast as possible. So as long as there is no lag between the two, or very minimum, you shouldn't lose messages, or you shouldn't have that ability, but it can happen. Duplicates, where you could see that happen is if you're trying to write to a sync, and what we do is we don't commit the offset until after we have written. So if the offset's not written and a job dies, we'll automatically launch a new one, and so it'll read from the previous offset, and so you may get duplicates. We do provide a GUID, so you can dedupe at the sync level. Duplicates is not as big of a problem. As I mentioned, we can dedupe. So more numbers. Average latencies for our S3 sync, it's 3 seconds. About a second for our real-time branch for stream processing. Elasticsearch, there is some backpressure there, so we are able to deliver messages a lot faster than Elasticsearch can handle, and so we do have some backpressure, and so we're about 400 seconds. Percentile-wise, like I said, I'll share all this stuff. I want to get to more questions.
Don't want to interrupt, but while I have everyone have a security announcement, this phone was left at the desk. There's a picture of this pretty girl in a gold dress.
All right.
It's at 10%, so I want to get it from while it's there.
There you go. So alerts, if we're dropping more than 1% of messages, we'll alert on that. Lag, as I mentioned, from the routing perspective is really important. So it's a 0.1, consumer stuck on partition. Dashboarding, very important. What we do is we provide multiple views for people. So as this is our general view for producers or consumers, you can see data flow. It provides kind of a 10,000 foot. You can drop down. You can see what's going on by topic, by app. What's the loss? What are your throughput rates? Internally, we track slightly different things. One of the things that we're building is people to be able to do self-service data streams. When you get that, you'd automatically get your integrated monitoring, all your dashboarding for people. So really kind of productizing the visibility. This is actually pretty interesting. It's a visualization of our environment. And fortunately or unfortunately for this demo or this talk, everything was green. But the intent of this is it provides us visibility into our environment, and we quickly can see the health of our clusters, and we can do it table form or chart. So for example, there, trace annotations, health was 99.53, but these will change colors depending on the health, and so it allows us quickly to go through a large environment and be able to identify things that are misbehaving. So next steps for what we're doing, self-service tools, I've touched on it a bit through this talk. Better management for people that are interested in running these environments. Please reach out. We're always happy to talk with people about what they're doing, how they've solved problems. On the routing layer, we need a more capable control plane. Avro we talked about. The other two big things that we're working on this year are providing a messaging as a service, general purpose messaging as a service for the rest of the company. If you look at the pipeline, there's multiple steps, and so what we're going to end up doing is providing the ability for people to do pub sub, but have that as a service. The other one is stream processing as a service. So there's right now a few different technologies out there. What we're trying to solve ultimately is a multi-tenant system where people could submit their jobs. They don't have to worry about the underlying technologies. I may want to do a join, a filter. I may want to do some computation. And so you have variance in what those workloads look like. So we're going to build a general purpose stream processing environment for people. Any time for questions? Or did I talk the entire way? All right, any questions?
Why Samza?
So Samza works really well with Kafka. And part of what we need in the routing service is the ability to checkpoint, handle backpressure well, because we're trying to do it at least once. And so we looked at Spark streaming. The problem with Spark streaming at the time, and that was earlier versions, is it didn't handle backpressure. And from a scale perspective, like I said, we're processing 1 trillion messages right now. And so we have worked with the community, the Spark community. I believe either the 1.5 or 1.6 was supposed to have backpressure work done. We are evaluating it for stream processing. Mantis, or in-house stream processing framework. There's right now a lot of use cases that are using Mantis. So yeah, I think for routing, we had very specific latency and SLA requirements, and Samza fit that profile really well. Thank you much.